So today is when we bring the entire last unit together with probability. So these are extremely challenging / impossible if you don't know the last unit well. Now, according to our marks, you guys got last unit pretty well, so this shouldn't be a barrier. Now, I want to come back to this question because a question like this is one of those where I was trying to kind of say, you know, the night before your diploma, make sure you get the best sleep, right? It's for questions like this that you're going to need to actually be able to think, right? You won't be able to put program stuff into place. So we're going to come back to that. But I want to talk about the key ideas that we talked about before, and that's the fundamental counting principle and permutations. We use those when. Thank you. When do we use fundamental counting principle and permutations? When order matters. Okay, and we use combinations when order doesn't matter. Okay. Hopefully you're not going, really? Because that would be bad. Okay. So, and then one more time, use permutations when order is important. Use combinations when order is not important. Okay. But remember that fundamental counting principle and permutations are synonymous, and you use the counting down method when repeats are not allowed, and you would use the 10 times 10 times 10 times 10 if any digit would be allowed, right? So example 1, they will have on the diploma. Okay? I've got it on my quiz. I've got it on your unit exam. I've got it on your, because we're doing 2 review days for this one because it's such an important unit. I have a quiz for you the second review day, right? Because I want to see if you can get it all in together. But I have one of these on there. Now, you have these 3 people, okay? Jamal, Ethan, and Alberto. And they are competing with 7 other boys to be on the school's track team. So first of all, how many people are we dealing with? Okay, 7 or 10. Okay, so we have 10 people. Now I strongly encourage you write that on the top because they may say Jamal, Ethan, and Alberto are competing, or are part of 7 people competing. Okay, when they're part of 7 people competing, then all of a sudden we have a 7. I'm okay. Okay, so we have 10 people. Now, here's where it gets, all the boys have equal chance of winning the trial race. What's that trying to say? That there's no advantages out of either one. And that's kind of important to know, or else it would change things dramatically to like second, third year university level, right? If each person had different odds of winning as opposed to just the way they would come in. So determine the probability that Jamal, Ethan, and Alberta will place first, second, and third in any order. Now that's weird, right? Because it's like you giving me positions and saying in any order. So is it a perm or is it a com? I still want you to look at this as a perm because they're saying those 3. What are the chances those 3 will come in first, second, third? Switch them. Maybe Jamal comes in third, Ethan second. So they still are unique. They still have positions. Okay? So we have first, second, and third are my positions. So we have first, second, and third. This would be my 3 positions, right? So if I have 3 positions and I am picking a group of 3 people to fill those positions. 3p3. Does anyone know what 3p3 stands for? 3 times 2 times 1. There is 6 different permutations they could come in. Now, that is what we would call the favorable outcomes, right? Well, that equals 6, by the way. Okay. Now, so there's 6 possible ways those 3 could come in for second or third. Does that make sense? Okay. Now, how many ways, how am I going to pick total outcomes? Okay. So total outcomes, how many people? 10 P3. Now even right now you go, well, that makes sense. Okay. So we have 3 people, we're picking 3, that's for those people coming in, the favorable, and 10 P3 are all the different ways everybody could come in first, second, third. Okay. So this is all the ways everyone could come first, second, or third. And this is all the ways 3 people could come in first, second, third, okay? All the ways 3 people could come in first, second, or third. So because of this, I'm going to say that order matters. But there's a sentence that it says right after, it says in any order, okay? Really a mixed message, right? But I want you to have, I want you to have a lot of confidence in your diploma that they just want to see those 3 can come in any order, but first, second, third is different than, like if it was Jamal, Ethan, Alberto first, second, third, it's very different than Jamal third, Ethan second, and Alberto first, okay? So, and that works out to be 720. So this is how we would write it. We would write, okay, this equals 720. We would write the probability of G, E, A finishing, those are our people, right? Jamal, Ethan, finishing first, second, third, in any order, would be 6 out of 720, which equals 1 or 120 to 0.0083, which is 0.83%. That's all the ways that it could be answered on the diploma. You like that, Janet? Okay, now, here's what I want to throw this out. If you go 3C3 over 10C3, guess what you get? 0.0083. So, because it says in any order, and it says positions, I have found both work for all. I don't know why I'm telling you that, because I don't want you confused. When you see the exact positions, like if it just says those 3 people are moving on, top 3 move on, I would go straight to combinations. But they're like first, second, and third. How many ways could those 3 people come in? They are actually talking about order. Now, here's what I don't want you to get this question mixed up with, is what if we say Jamal comes in first, Ethan second, and Alberto third. How many ways can Jamel come in first, Ethan come in second, and Alberto come in third? One way out of 720. So this is where you do want to be using that. This is where both will obviously fail you. You wouldn't be able to put 10C3 and get that right. So if you want to be safe, stick with perms with these. See, I'm saying Jamel comes in first, Ethan comes in second, Alberto comes in third. How many ways can they come in if Jamel has to be first, second, third? Just one way, right? When I was saying those three could come in 6 different ways, first, second, and third, in the first question. Okay? So when they say for sure, he comes in first, he comes in second, he comes in third, that means they can only come in one way, or there's only one way for that to happen. Right? Is there 2 ways for that to happen? No, it doesn't make sense. Is there 6 ways for... Okay, that's just weird. I lost my mouse. Okay, is there... I wonder if it's unplugged. Is there 6 ways for this to happen in any order? Yes. Okay? Now, here's another one that, again, these are all diploma questions, right? After 20 years after graduation from high school, Blake, Mario, and Simon met at the mall. Blake had 2 daughters with him. He said that he had 3 other children at home. Determine the probability that at least one of Blake's children is a boy. Now, what's really cool about this is we are just talking about the 3 at home, right? Because if he's got a boy with him, what's the probability? He's got a boy. 100%. Okay? Like, if I had my son with me and I go, I have at least one boy, yeah, there's a 100% chance he's right there. Okay? So, the thing we got to look at, now I want to do it totally old school here so you can see how this works. Now, we're just talking about the 3 kids at home. So we have number 1 could be a boy or a girl. Number 2, right? Boy, girl, girl. And then number 3, boy, girl, boy, girl, boy, girl, boy, girl. Okay, so these are all the combinations that could be at home. Boy, 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 girl, boy, girl, boy, boy, girl, girl. Okay, then we have girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. Now, just by these 3, how many of them have at least one boy in them? There is at least one boy. How many? 7 out of 8. There's a 7 out of 8 chance. Okay, that one, that one, that one, that one. At least one boy, at least one boy, at least one boy. Okay, so that's how you can solve that one, right? Like that. Now I do, you know how like sometimes you learn these kind of methods and they're like, oh man, that thing is so time consuming, I would never do that. This is the best way I know not how to miss anybody, right? Because sometimes you're doing them in your head and you're like, okay, yeah, boy, boy, girl, and then I move the B over, and we have our little strategies, but sometimes later we put the same one twice, and we don't see it. This one really helps you so you don't get the same one twice. Now, here is the other way to do it, and this might be just asked on the diploma. The probability of at least one boy, it'll actually equal 1, because 1 is 100%, minus what? I don't want a number, I want the words. 1 minus what means at least one boy. What's the complement of at least one boy? Hmm? 3 girls, right? 1 is 100%. So probability of at least one boy should be 1 minus all girls. So that could just be a, do we have any all girls? Yeah, we have 1. So according to what I'm saying, the probability should be 1 minus 1/8, which would be 7/8. Okay? So they might just ask you this question on the diploma right here. Probability of at least one boy, what does it equal? And they'll have 4 word formulas on the diploma. Okay, here's another way that we could do it. Okay, because we did this with the last one with cards, it would be at least 3 jacks, right? Or at least 2 hearts. So at least one boy would be 1 boy, 2 girls, or 2 boys, 1 girl, or 3 boys, 0 girls. That means at least 1. So, what does that mean? Well, this would be like 3C1, because 3, we're doing 1 boy, and the other 2 children are girls. 2C2 plus 2 boys would be 3C2, 1C1, and no girls would be 3C3. Okay, and this works out to be 3 plus 3 plus 1, which equals 7 out of 8 possible scenarios. Okay, and the way you get your 8, another way is there's 2 options times 2 options times 2 options is 8. Okay, so it's like when you flip a coin 3 times, or 3 coins I should say, it's 2 times 2 times 2 outcomes. So believe it or not, this is a coin question, because boy, girl, there's only 2 options. Heads, tails, only 2 options. So there's 3 ways to do that question, but they all mean the same thing. And the only difference of this one from last day was the fact that we just put it over 8 now, or not last day, I meant last unit. Okay, now they'll ask one of these questions too. Okay, so we'll host a morning show in Saskatchewan. To advertise his show, he's holding a contest at a local mall. He spells Saskatchewan with letter tiles. He then turns the tiles face down and mixes them all up, and he asks Sally to arrange the tiles in a row and turn them face up. If she spells Saskatchewan, she'll win a new car. Determine the probability that Sally would win a new car. Okay? There's a diploma question for sure. So, total outcomes. We know how to do this. Who can remember? You could have done this on the last unit. How would you do this one? What's in this question? What's in it? Repeats. How do we handle repeats? What are our repeats? That's the other thing, right? They're not going to tell you. What are the repeats? 3 A's and 2 S's. Okay? How many letters? 12 letters. So this would be 12 factorial over 2 factorial, 3 factorial. And that gives us, what is it, 3,991,000. Nope, 39,916,800. Split my 39 over here. Okay? Now, because I took out all the repeats, you're good to go with there's only one way you're going to get it right. So it's 1 out of 39,900 or 39,916,800. So this is probability of winning. Okay? Like, I just hope you see this one in the diploma. You guys know how to handle this one. Find out how many outcomes by number of letters divided by the number of repeats, and there is one way to win it. Okay? I'm trying to go through these diplomas. I'm seeing what's on there all the time. There's always patterns. There's always repeating kind of questions. Okay? And number 4 would never do on a diploma. Okay? So we're doing page 64 and 65 and do 1 to 7. Okay? Again, it's really important you're getting through these, number 1. And number 2, that, yes? Oh yeah, sorry. I would like to get to the investigation, because I'd like to see if as a class we could figure this one out. Okay, thank you for reminding me. Okay, A, B, C, and D have booked a flight to Florida. The airplane has 4 seats in each row, and they're planning to sit in the same row. So that means, so yeah, they're all going to sit here. See where it's, you can see it, right? A, B, A, right there's just one way they could be sitting. What is the probability that Cam and Dan, so C and D, will be sitting on the same side of the airplane? Now, can you give me one scenario? Can anyone give me one scenario how they could sit on the airplane? Just say the letters to me. Okay, so we got A, B, C, D. And do you see how I'm putting the aisle here? So this will be my aisle. There's one. What's another way? Okay, let's keep them on the same side of the airplane right now till we exhaust all of that, or else we're going to... So A, B, D, C. Okay, there you go. B, A, C, D, and B, or A, B, no. B, A, D, C. Okay. Can't do A, C, D, C. They don't want to sit beside each other. So that's... Now, let's put them on the other side of the airplane. Is there any more ways I can put them on that side of the airplane? Okay. Now, let's put them on this side. So we'd have CD, AB, and DC, AB. Okay. Then we would have CD, BA, and DC, BA. Okay, so we got favorable. Favorable is 8. There's 8 ways they could sit. Okay, what's the total? Because they want probability. Now if I can get the total, done. Yeah. No, see that, what's the probability that Cam and Dave will be sitting on the same side of the airplane? So if you did this, they're not sitting on the same side of the airplane. Okay? Yeah. Not filling the requirement. Okay? I don't want to get into why they're doing it. I really don't care. They asked me the question. I got to answer it. I'm moving on. I could see you guys in the hall after. Like, why'd they ask that? Like, why'd they have to subside each other? Is there a problem? They're scared? What? What's the deal? Okay? Don't worry about it. Don't get involved. It's math. Okay? You stay out of it. Okay? As a class, how can we get through this one now? Because I need probability. It's got to be 8 out of total. 4 factorial? Okay, it actually is 4 factorial, right? Because order matters, doesn't it? So 4p4 or 4 factorial or 4 times 3 times 2 times 1. Just, you know, they all mean the same thing. So you would get, that's 24. So the answer is 8 out of 24, which equals 1/3. Okay, now here's, and if this way makes sense to you, that's awesome, right? Here's a way that you could do it. So if you're on left side, it's, so for CD, that's 2p2, right? There's 2 ways I can do that. And then if they're on the left side, on the right side will be those other 2, right? So that's A and B. They can be 2p2. And that would all be over 4p4. Plus for the right side, now we're going to do CD over here and AB here, right? So I have 2p2, 2p2, all over 4p4. Now it gives me the answer 4 over 24 plus 4 over 24. Now remember, when you add, you do not add the denominators, do you? Right? So that will be 8 over 24, which is 1/3. And they've actually had this one on the diploma, which probably means they won't again. But they'll have something along the same lines, right? And just even have kind of, I remember seeing that. I remember us doing this. Like, that's a huge advantage, right? Like, I remember us doing this, right? And if you do this, like, some people are just awesome at this, and that's why you need that good night's sleep, right? You can do that. You can think about it, right? That's what's going to get you through this part of the test, right? You don't have to go and do this, obviously, because we did it without it. Okay? These definitely take practice. And kind of like yesterday with the odds and the, you know, once you get them, you'll really get them. But if you don't practice them, then you're going to see that on the quiz, and you'll see that on the unit exam, which of course we don't want, right? We want you to do well. So everyone, page 64, 65. Again, don't pack up early and bug the people that are trying to finish, because they get distracted.